Okay, so in our previous class we have completed till up to Eigrp topology table and the Eigrp routing table details and show command,
Yes.
right?
Routing table.
Yes. So today we are coming to know
Yes.
few changes of Eigrp. Okay. So normally if you will come to configure Eigrp, so we normally what we write? Router, right? Router 1,
EIGRP.
router Eigrp, whatever autonomous system number. Okay, then here you will get
Autonomous system.
this router, and then here we type network and the connected networks like this, right? Whatever network you want to advertise. Okay, and then we write here no auto somebody, right?
Yes.
Okay, now Cisco has given multiple options to configure. Okay,
No auto.
so this was the old configuration. After this we will be talking about new configuration. Okay,
Yeah.
like initially when we were using
Yes.
12.4 12 point something iOS, at that time we were using this old configuration, right? But when we use new configuration we'll see the difference. Okay, so here according to scenario or according to lab, what is written here? Note, advertise
Okay.
only 12.1.1.0 WAN link.
Okay.
Yeah, so here what recommendation is here in this lab? Please do not advertise this link, this network. Please do not advertise this network, and please do not advertise this network as well, right? So if you do not want to advertise, so if I'm coming here, let me come to this network, start all the devices. So IP addresses are configured here as per given scenario. PC1 and PC2 belongs to 12.10 network, and PC3, PC4 belongs to 12.20 network.
Mm.
Okay, now R1. So if I'm coming to R1, let's verify the IP address. So IP interface brief exclude unassign. So you can see here on R1 you have 5 interface. You can see here F0 by 0, F1 by 0, F0 by 1 and loopback. So 5 interface. So here also 5 interfaces are okay here. On ISP also if you want to verify,
Not, not four.
yeah, on R1 you
It is
have
not four.
okay only 4 interface 12.1.1, 12.1,
Four.
2, 3, 4. Okay, sorry, 4 interface. So you have 4 interface here. Okay, fine. ISP is so IP interface
Yes.
brief
Yeah.
exclude unassigned. Yes, IP is there. Now we are configuring routing. So here the recommendation is there if you want to check here. So IP protocol, nothing is running. So here what recommendation is there, that you have to advertise
Okay.
only this 12.1, this WAN link. Okay, this WAN link you have to advertise.
Okay.
So according to the older configuration, if you try to advertise only the WAN link, router EIGRP10 network, you can write here no auto net network 12.1.1.0 and no auto. Fine. And now if you're coming here to ISP conf t router EIGRP10, okay, network. So here let's just run default network because we have to check only R1 configuration. Okay, so let's wait for the neighborship. Why neighborship is not coming up? 12.e. Okay, interface is wrong here. Can you see the problem? See, here I am using E0 by 0. Can you see? And here the interface IP on E1/0, right? Okay, so what we can do here, conf t interface E1/0. First you have to say no IP address, and then you have to come to interface E0 by 0. IP address is 12.1.1.2 and subnet mask 255.250 and no shut one it is. Now let's see whether the neighborship is coming up or not. Yes, neighborship came up. Okay, and now if we are coming on R1 neighborship came up. So see what you did on R1, you have advertised only your WAN link, right? But if you're coming to ISP router, okay, other side router, and if you'll check here, so IP Eigrp or so IP route, you can say Eigrp. See, your all network is coming here. 12.14, which is this network, loopback network, your 10 network, 12, 20 network, all the networks are advertised. Okay, so and even if you'll come here on R1 and if you'll check here, so IP protocol, even if you'll check here, see, even you have disabled summarization with the help of no auto. In that also it all networks are advertised. Okay, see why it is advertised. Normally uh, we have written this command. So when you will write this command, the router what we are using here, this router, okay. So what this router is saying that whenever you will write, so router will say that if you are writing like this, okay, and you are not defining any kind of subnets, if you're not defining any kind of subnets, okay, so router will think that now see how it is traveling. When this router R1, you can say here is R1. So here you can say this is R2. Okay, okay. So whenever R1 is advertising this 12 network, okay, okay, this 12 network. So what will happen when this R1 will start advertising this 12 network, and it will advertise like this 12.1.1.0, and this advertised network will come here on R2. R2 will say that I have received 12.1.1.0, but there is no subnet mask, right? So if there will be no subnet mask, what will happen? R2 will say that no problem. If there is no subnet masks, so let me check that first octet. Okay, this first octet belongs to which network? So okay, you belongs to class A. No problem. What is the subnet mask of class A? Okay, so subnet mask of class A is 25500. So it will say that 12.0.0.0,
0, 0.
and it will say that, okay, and it will put like this 255.0.0. Okay, so it will put in the routing table like this 12.0.0 by 8. Okay,
Okay.
it will understand like this. Okay,
Okay.
now tell me, all the network what you have kept here, all the networks. So here we are using 12.1.1.0. Here we are using 12.10.1.0. Here we are using 12.20.1.0 and 12.1.1.4. Four network we are using. Okay. Now when router 1 is advertising all this network like this, saying that now advertise
Yes.
12.0.0.0. Okay. Now here is saying that please advertise all network which octet is matching with the first one. Okay, whichever network octet
Yes.
is 12, please advertise that one. So
Yeah.
you can see here, this one is also 12, this one is also first octet 12, first octet. So all these networks will be
Yes.
advertised from R1 to R2.
Okay.
Okay, R1 to R2. Okay, so to resolve this problem, this was a problem because see, companies do not want to advertise each and every networks to internet. So companies say that no, I want to advertise only limited networks.
Yes.
Maybe I want to advertise maybe this one. Maybe I want to advertise this network, but I do not want to advertise this network, because this network is maybe my private network. Okay, so if you will advertise with this default route, old Eigrp configuration, okay, so you will have a lot of problems, and the problem I have explained you, because your router will say that no problem, whatever first octet is matching, please advertise. So here also first octet is same, this network will be advertised, this one will be also advertised, and this one will be also advertised. Now to stop this problem, solution is the new Eigrp configuration. So in new Eigrp configuration, you have two
Okay.
options. Either you advertise with subnet mask, okay, or
Support.
you advertise with
Yes.
the wildcard mask. Okay, so
Wild.
if yes, and what is
Okay.
wildcard mask? Opposite of subnet mask is known as wildcard mask.
Positive
Yes,
support.
or you just
Yes.
minus with minus your subnet mask with 32 bit. Okay, like
That's good.
suppose, yes, if I want to advertise, maybe if I want to advertise something like just come here. Okay, erase it. Now let's come to the scenario. Now we are using the new configuration. Okay, so in new configuration what we have,
Okay.
one we have with subnet mask. Okay,
Subnet mask. Yes.
yes, so in that, maybe in the new configuration I'm saying that okay, please advertise 12 dot the WAN link and 1210. So here if you want to advertise with subnet mask 255.252. Okay,
Yeah.
okay, and now here you can advertise 210 and the subnet mask is 248. 248. Okay, the second configuration. Now let's come here, come to R1 conf t, simply type here router eigrp 10 and no. So the routing table has been removed. Okay, and now router eigrp, router eigrp 10. Okay, no auto, Now you want to advertise network 12.10.1.0 and the subnet mask is 248, and then again network you want to advertise 12.1.1.0, but here the subnet mask is 252 and no auto is already there. Okay, now neighbor came up. Now see this ISP. So IP route, see your ISP is getting only the network what you have advertised. Okay, so you are getting only this network 12.1.1.0/30. Okay, and now if your ISP will try to ping ISP users or maybe outside internet users 10.23, yes. Oh, sorry, I'm pinging to 192. Ping 12.10.1.2. Yes, communication is there, no problem. Okay, but when they will try to communicate to maybe like 20 network, they won't be able to communicate because there is no routing. And if you are coming on R1, see how it is advertised. So IP, so running config. You have advertised through subnet mask, but that subnet mask will be converted to wildcard mask. So here you have option that you should advertise through wildcard mask or through subnet mask is the same thing. Okay, if you want to advertise through wildcard mask or subnet mask is the same thing. Now see, now let me come here, let me delete this and let me advertise through wildcard mask. And how to calculate wildcard mask? 00003, and here is
Yes. 007.
00007. Okay, and how it is like that, let me show you with this. See, if we are using this one, so we normally what is the 32-bit subnet mask? 255.255.255.255. Now you have to minus with your subnet mask.
Yes.
So if you want to advertise, so my subnet mask is
Yes.
255.255.255.252. Okay, now you
Yeah.
see here 252 means 0,
And
right?
0.
Yes, now again
0. Yes.
here also 0.
0.
Okay, and then again if you'll come here also 0, and then if you'll check
0.
here minus,
And
yes,
this
it's
one.
3. Is it okay?
Yes.
Okay, now if you are calculating this, why it is 007, so what is my subnet mask? So let's take 32-bit. Okay, my subnet mask is 255.255.255.248.
Yes. 0. 0. 0.
Yes, 0,
0.
0,
0.
and 7. Like this, very
7.
simple. So you want to advertise with subnet mask or wildcard mask is the same thing. It whatever you are going to put the value in subnet mask, it will be converted to wildcard mask automatically.
Okay.
Okay. So this is our new means like EIGRP configuration. We have other EIGRP configuration that we should only advertise on interface. So we will come here to the interface and we'll just advertise on interface. So we'll see that new configuration
Okay.
again.
Like the configuration of OSPF.
Yes, yes.
Okay.
Okay. Okay. Now here we have to understand about EIGRP packet flow. Okay. So how EIGRP packet flows are working. Now when you are coming on this EIGRP router 1 and you are advertising at this network like router EIGRP 10 network 12110 and no auto something, right? So if you write this command, so what this router 1 will do, see, if you'll write this EIGRP, if you'll enable EIGRP, router 1 will generate one EIGRP packet, okay, and that EIGRP packet is your hello packet, right? Without hello, there will be no any kind of update, right? Hello first, hello is there for building the neighborship, so it will generate that hello packet, okay. Now, as you know that EIGRP works on layer 3,
Yes,
okay.
yes.
So this hello packet which is coming via layer 3, it will be given to
IP.
IP, right? Because we have two type of two protocol, IP and TCP, right? So
Mm.
so here EIGRP do not work on TCP. So EIGRP has its own reliable transport protocol. Okay, so EIGRP works on layer 3, so it will give to IP, because uh, finally these hello packet, update packet, they are the routers are transmitting those on behalf of IP, whether it is multicast IP or unicast IP. So in this IP packet, okay, what will be there? Okay, so EIGRP will encapsulate the hello packet, okay, with IP address. So it will say that, okay, I want to send hello source IP. This is my source IP, means I'm sending the hello packet from here. This is
Okay.
the destination IP. Destination is what? It's a EIGRP multicast IP address, right?
Yes.
Yes. And why it is sending on EIGRP multicast? Because first time it sends through multicast, right?
Yes.
It will not start unicasting. Okay. So it will say that 2240010. And then it will say that protocol 88. So EIGRP has its protocol number. Okay.
Mhm.
So it will say that, okay, it is protocol 88. So all this information will be kept in a single packet, okay, because IP address create packets, right? Sorry, layer 3 create packets, right?
Yes.
Okay, once this packet is formed here on the layer 3, okay, it will be transferred to layer 2.
Yeah, too.
Yes, and then on layer 2 there is one protocol which is known as ARPA, okay,
Yes.
ARPANET, okay, ARPANET has created this protocol, so ARPA is there, okay. Now this ARPA will get this packet, then see ARPA or layer 2 do not understand this packet, so they will keep these packets side, and then they will understand, okay, they will put that, okay, this IP address, MAC address is this one,
Mhm.
okay, and then they will check, okay, Ethernet frame, this is known as Ethernet frame, okay, and then they will say, okay, what is the destination, this source MAC, this, what is the destination MAC? Destination MAC is multicast MAC address. Why multicast MAC address? Because there is a multicast IP address. So
Yes.
on behalf of multicast IP address, there will be multicast MAC address. Okay, and
Okay.
the calculation is there by default. Whatever the IP will be there, according to that there will be MAC address. Now here will be type. Okay, type means who has given me this packet. Okay,
Okay.
so the IP packet type, okay, who gave me this, who IP has given me this one, or TCP has given me this one, or UDP has given me this one, okay. So here you will have the information of IP packet type. IP packet type code is 0x0800,
Okay.
okay. So it will say, okay, fine, I got it now. Now it will after layer 2 this frame will be formed,
Okay.
okay. Now this frame is formed now, okay. After once the frame is formed, it will come to physical layer, okay. So whatever bits is there, it will be converted to signal, okay, and then it will be transferred through wire. Okay, now it will come to the second computer or second router. Okay,
Okay.
received on the interface. So that interface will convert these all bits to signals
Binary.
to bits. Okay,
Yeah,
and it will
bit
hand over to,
binary.
yes, it will hand over to again layer 2, right?
Okay.
Yes. So see, once it received this on layer 2, maybe it is coming here on layer 2. Sorry. Okay. Now it same frame. Oh my God, frame is came here. Wait one second. Okay. So now we were talking about this frame. Okay. So finally that frame has received on layer 2. Layer 2 will hand over to ARPA. ARPA will get this frame, and this frame is coming from R1, right?
Okay.
Okay. So in that frame, he will R2 will see that okay, there is packet, but I cannot do anything with this packet. But where I should forward or to whom I should give this. So here it will get the detail. He will say that okay, first who is sending me? He will get okay, R1 is sending me, okay, and this packet is for whom? Okay, so this packet is for multicast, okay. So which multicast?
Yes.
So they will just come to know okay, this is the multicast MAC address, so I have to forward to the multicast MAC address, okay. And okay, so this frame after in decapsulating it, okay, after decapsulating it, I have to give this packet to which layer? Okay, layer 3. Okay, and in layer 3 to whom? TCP, UDP, IP. So here it is written that okay, you have to hand over this packet to IP. Okay,
Okay.
so what this switch 2 will sorry R2 will do, R2 will remove this encapsulation frame, okay, this one, this frame, and this packet he will send to upper layer R3,
In
sorry, layer 3.
yeah,
Okay,
in
in
the
layer
customer.
3, okay, it will receive here. So layer 3 it will say that okay, this packet is for IP. Okay, then it will open that packet and you will say that okay, this is hello message, who is sending me, and it is for whom. Okay, and this hello, who is sending hello? Maybe eigrp is sending hello, reap is sending hello, ospf is sending hello. So they will say that okay, this is for eigrp hello. Okay, who,
Okay.
and then it will say that okay, this is for eigrp hello. It will come here. Okay, it will hand over to eigrp because of this multicast address and this port number, and then eigrp hello will be transmitted to R2. Okay, like this it works. Now someone will ask like that okay, what is the difference? Like normally when we started the eigrp, we have seen that RIP support only classful routing, RIP 1, right? Okay,
Yes.
yes, but eigrp supports classful routing as well as classless
Classless.
routing, right?
Yes.
Now, but if we will configure classful routing in eigrp, what will be the problem? Okay, now see. Okay, this is our router 1. Router 1 will
Yes.
configure one network which is 10.1.1.0/24. Okay. So in the router 1 routing table, that network will be like this C connected, right?
Yes.
And connected via E1 something like that, the interface name. Okay, and once you will enable in
Okay.
eigrp, so R1 will start advertising this network. Okay, so
Okay.
it will advertise like this. Okay, and it will not write any subnet mask. So when this router will receive anything on this interface, okay, it will say that okay, I received one network via eigrp, D means eigrp, but there was no subnet mask, so I
Okay.
considered this belongs to class A. So I said okay, let me summarize it to class A, and I will write like this in my neighbor table, and I will say that I received this network from my neighbor R1.
Yes.
Same, this R2 will advertise this network to R3. Are you
Yes.
understanding? Same, but see,
Yeah, I
when
see.
R1 was advertising like this, 10110, but no subnet mask, right?
Yes.
Now here I forget one thing here, but when R2 will advertise this one to R3, yes, he will put subnet mask. Are you understanding?
Okay.
Okay. So here the R2. This R2 will advertise this routing table to R3 neighbor. So now R2 know about this network. So R2 will advertise like this 10.0.0.0/8. So
Eight.
yes,
Yes.
so R3 will put like this in the routing table, right?
Okay.
Now, now see, R4 is using some different network subnet. Can you see here? He is using
Yes.
10.10, and here R1 is using 10.1. Okay,
Yes.
so R4 will send this network to R3 as 10.10.0.0, but no subnet mask, right? So R3, what R3
Yes.
will consider? 10.0.0/8, right?
Yes. Yes. Same thing.
Okay, same thing. Okay, so when R3 is receiving same route from R2 and from R4, are you understanding?
Okay.
Okay, now,
Yes.
so not R2, but actual originator is R1, right?
Yes.
Yes. So you can say that R3 is receiving one network from R1, and R3 is receiving one network from R4 as well, right?
Yes.
Now tell me, R3 will keep which router network? R2 sorry, R1 router network or R4 router network? Because it's same, right? So any
The same.
router, no, any router cannot keep same update. See what happens there.
Yes. So
Yeah, it will keep R4 or R1 network.
R4.
Why?
Because it's the one that's that.
But R1 has sent first, right? R1 has
Yes. Yes.
R1 has sent first. R4 has sent second.
Okay. Okay. So he's gonna keep the first one.
No, I'm just asking question like an interviewer.
Yes.
So don't get confused. Use now see what will happen. R1 has shared, no problem. R4 has shared. So when R3
Okay.
has received same network from two different destination, so R3 will
Okay.
compare with the metric, right?
Okay.
Okay. Now tell me which metric is lower, this one or this one?
R1. The R1.
R1 is lower or R4 is lower?
R1 is low.
Metric.
Yes.
R4 is
Metric is
R4 metric will be lower because see R3 is directly connected with R4, right? And
okay.
R1 is see one hop, two hop, and here
Two.
a single
Okay.
hop.
Okay.
So
Okay.
R3 will say that I will keep only R4 network, not R.
Yeah, lower.
Yes, this network, right? Now,
Okay.
now what will happen if this PC1 want to communicate? It PC1 will ping 10.1.1.1. So normally R3 will receive this packet. Why? Because the
Mhm.
request what PC1 has sent, it is related to this network, right?
Yes.
Yes. So it will say yes, yes, please send me the packet. I know where to forward. Yes. So R3 will receive this packet and it will forward here. R4 will say that no, I
Yeah.
am 10.10. I'm not 10.1
Uh,
dot 1 dot. R4 will reject.
yes.
Then here you will get here request timeout, right? This is the problem.
Okay.
But in actual, what should be happen here? When PC1 is sending packet, R3 has to send to R2, R2 has to send R1, and R1 will reply, right?
Mm.
But it is not happening. That's why they came with the solution of classless routing protocol. And in classless routing protocol, see what is happening. Same thing. Here see what is happening. R1 will say that yes, I have one connected network 10.1.1/24. When it will
Yes.
advertise, it will advertise with subnet mask.
Okay.
Then R2 is receiving, yes, okay, I received 10.1.10/24 through Eigrp via R1, no problem. Let me keep it in my routing table. Let me advertise this one. Yes, 10.1.1 same network, advertise to the neighbor. Okay, so R3 will keep in the routing table like this. Yes, I received 10.1.10/24 through R2. R4 will also advertise this one with subnet mask. Here also it will keep here. And then when PC1 is pinging to 10.1.1.1, see now in here in the routing table you have the information, right, for 10.1.1
Mm.
plus 10.10. Also, so if you are pinging to 10.1. So R3 will receive the packet. It will say that okay, I have to forward to R2 will say that
Yes.
okay, I have to forward to R1. If data will come here, R1 will say that I do not have to forward to anyone, I have to forward to this interface, and it will forward to this interface, and this will reply.
Yes.
That's why they use this. Okay, and
Classless.
classless routing protocol will work when you will enable no auto summary. No auto summary means, see here, initially, see, right, Eigrp is by default classless routing protocol, right? But before Eigrp there was
Okay.
Igrp. In that Igrp they were using classful routing protocol. So Igrp
Okay.
was, yes. That's why here saying why we are not using Eigrp as a classful, we are using Eigrp as a classless. In classless, we are using this command as a no auto summary, but no problem if you will not enable no auto summary, but in the some newer iOS, no auto summary is already
Okay.
enabled. Are you understanding?
Okay.
So we will verify this one. So for verifying this one, we'll come to the same lab. Let's change this
Okay.
router, delete this router, let's have a new router. (12.1.1.0/30) E1 fine. Here we are running Eigrp 10. So all the device configuration is okay. We have to configure only the new router. So
Okay.
IP interface brief exclude unassign. Yes, IP is there. Okay, R1 IV connected new. If you check here, show version.
Okay.
Okay, it's 15.4. Okay,
Before.
yes, and
Oh,
if you
this
check
one is
here,
the last
so
version.
yes, so IP protocol, no IP protocols are running here. So we'll configure. We have four interface. So interface E1/0 IP address 12.1.1.1
Okay.
no shut, then interface E0 by 0 IP address 12.10.1.1 248 no shut, and then interface E0/1 IP address is 1220 no shut, and then we have interface loopback 1 IP address 12.1.1.5. Okay, in loopback, save it. Okay, so IP interface brief exclude unassigned. Fine. Now we are configuring routing. Okay, so first type here router eigrp 10
Yeah.
exit. I
And
just wanted to show you something. See, so IP
okay.
protocol. See here, auto summarization is by default disable.
Disable.
Yes, but you
Really?
remember yesterday I have shown you that auto summarization was enabled in some older iOS router, right? But here is auto summarization is by default disable. And if you are coming here and if you are typing here router eigrp10
Yes.
net
No.
network 12.10.1.0 00007
Yes.
1227 and 12.1.1.1. If you want to advertise like this also, you can advertise with this IP address also
Okay.
00003. Okay, no need to write. Okay, I have already enabled no auto.
Okay. Yes.
No, no, no auto summary. Auto summary. So IP pro protocol. See,
Never.
no. I did some mistake. I enable manually, right?
Yes.
It, by default it was disabled, so no problem. What I can do. Let me stop and start. I just wanted to show you that if I'm not writing no auto summary, what is going to happen? Okay.
Yes.
So IP interface brief exclude unassigned. IP is configured. So IP pro protocol, no IP protocol. Conf T router eigrp 10 net
Ten.
network. I just wanted to advertise this network 3
Okay.
and maybe this one exit. And if you are checking here, see, so IP protocol, see, auto summarization is disabled, right? By default it is
Yes.
disabled, so no need to write. See, why we write no auto summary to disable auto summarization, right? But in the
Yes.
newer iOS you will already see that auto summarization is disabled, so no need to write it. So if you'll see here, I have advertised two networks, that those two networks are there. And if you'll check here, so IP protocol, so IP route, sorry. Okay, yes, you are getting only those networks. So in the new configuration of eigrp, we do not need to write no auto summary. Okay.
Okay.
Okay, now, okay, this we have seen it. Now we are going to know that, okay, if router 1 or any router is sending hello message to neighbor, okay, what information is there in the hello message? Okay, so let's come here. We will have ospf version, opcode, checksum, sequence number, acknowledge, as number, k value, hold time, ios version, and authentication key optional. This is optional. Now let's verify. So what we can do, we can come here, right click, start capture. Okay, so here we have enabled Wireshark. Okay, and then if you are filtering some packet here through Wireshark, you can see here hello message, who is sending 12111 to multicast, right? Hello, so hello is in every 5
Yes.
seconds. So let's read this hello message. Okay, in hello message, Cisco Eigrp, we see. So version, okay, version 2. So now tell me, this version is for Eigrp version 2. Okay,
Yes.
so here
Okay.
Eigrp, okay, opcode means you are sending hello packet. Okay,
Okay.
and opcode is 5. See here in this slide also I have written opcode. Whenever you see opcode 5, 5 means hello message.
Okay.
Okay, then if you are coming here checksum, checksum means there will be checksum, any type of checksum code will be there, but it start from 0xe. Okay, and then see checksum means it checks whether there is any error in the packet or not. Okay, so yes, checksum
Okay.
is good,
Okay.
correct, fine, flag is there, no problem. Now see sequence number 0, so hello will be always 0. Okay, see sequence number means what? If I will send you some higher sequence number, right? See, if you'll come here to the neighbor, neighbor ISP, we'll check here. So IP EIGRP neighbor. So what is the sequence number? 4, right?
Four.
Yes, I'll show you after this hello message. Okay. So sequence number
Okay.
in hello, it will be always 0. Same like revision number. If it
Okay.
is higher, means
Yes.
there is some update.
Yes. Some
But in hello, hello is not update,
change.
right?
Yes.
So that's why hello sequence number will be always 0. So if sequence number will be always 0, so acknowledge is what? Always 0.
Zero. Yes.
Yes. And then what? Router ID. Okay. So here we will understand when you will enable address family, then you will understand. But normally you always keep in mind
Okay.
EIGRP also use router ID same like OSPF. See here.
Okay.
If you are coming here on R1 and typing here, see, so IP protocol, router ID is what? 12.1.1.5.
12.
Yes. So EIGRP also use router ID, same like OSPF.
Okay.
Okay. But we'll see what is the use of this router ID later. Okay. Now acknowledge is done. Then see autonomous system number. AS number is 10. Okay. Okay. Now tell me what you remember. I told you that whenever computer communicates, right? So computer communicates through digital or digitally or decimal value. See here we are getting also autonomous system
Digital.
number 10, right? But see,
Digital.
yeah,
Yes.
digital, or you can say binary language, right?
Yes.
Yes.
Binary
So
one.
see 10 is converted to binary. Can you see here? 10 is
Okay.
converted to binary. So what is the in the binary? 10 is 0 in
Yes.
hexadecimal, right? Remember 10 is
Yes.
0A.
Yeah.
A is what? A is
Yes.
10,
Zero.
right?
Yes. 10. Yes.
Okay, and if you will get B, B means 11.
Okay.
Yes,
And C 12 values.
yes, yes. Okay. Now there are some parameters. So let's understand about parameters. Parameters are like, see, K value. So see here in
Oh
this hello
yes.
packets
C
there will
value.
be K value, and K value must be same, right?
Yes.
Okay. Hold down time. Hold down time means what? Means how
Good.
long you can wait for hello message. And there will be software version, means router 1, is it a newer EIGRP, like, yeah, sorry, newer iOS version or older? See here, the iOS version is 15.0, means is the family of 15.0, So 15.1, 2, 3, 4, 5 like that. Okay. And
Yes.
here these are the TTL value. So Eigrp TTL value is always 2. Okay.
Okay.
This is the related to, okay, TTL value is not here. TTL value will be here. Eigrp TTL value. Okay. Time to leave. Okay. Eigrp TTL value is always 1, but maximum is
Okay.
2. Okay. Now see, in IP protocol, how it is traveling. See, IP version 4 you are using. Okay. Now you can see here something like, okay, this packet is for Eigrp, port number 88. Okay. Who
Okay.
has generated this packet? 12.1.1.2. For whom?
Well,
Multicast address.
okay. Yes. Yes.
Yes. Okay. And now if you're checking here, and we already know about this one, so I wrote this information that whenever you want to form a neighbor relationship between two routers, so these things must be
Yes.
same, right?
Have to
Direct
match.
link connected to the neighbor must have same subnet IP, es number
Number.
must
System
match,
number.
k value must match, authentication must match, and it is optional. Okay.
Okay.
Now update message. See, hello, why we need why, what is the need of hello message? So hello message is used to form neighbor relationship, right?
Yes.
Okay. And
Yes.
update message is used to exchange the routing table between the neighbors, right? So normally if you will see somewhere
Yes.
routing table exchange, or you can say they share prefix information. Prefix is also same. Prefix is the network, right?
Okay.
Okay. So it is
Yes.
used to share prefix information of routing table, okay, to the
The
neighbor.
number.
Means prefix or network is the same thing. Now it is an acknowledged message. Acknowledged message means whenever I'm sending you hello, it doesn't mean that you should also send me hello, right?
Yes.
But if I'm sending any update, you must acknowledge me that you have received an update from me.
Yes.
Okay? That's why it is written here acknowledged message. So update is always acknowledged message. Means if I have sent you something, I need acknowledge. If I'm not getting any acknowledgement from you, then again I will
Yes.
retransmit it.
Yes. So you have to make sure that you
Yes,
receive it.
yes. Okay, serial. Okay, now see, we have two type of link. One is serial link, and second is Ethernet family. In Ethernet family, we have Ethernet, fast Ethernet, and Giga, right? So serial
Yes.
link, if any router is connected with neighbor router with serial link, for example, if they are connected with serial link, so if they are sending some update, so serial link update is always unicast.
Unicast.
Yes,
Yes.
always unicast update. We will check this one when we will connect two routers, and we'll use Wireshark, and we'll see here. See, here with the help of
Okay.
Wireshark, we have seen that serial update hello message is always going through multicast address, right? See, multicast address 2240010. Even in the Wireshark, you can check here as well. See, update is
Okay.
going here on this, right? Okay, but if you will use serial link, in that update message will be unicast.
Okay.
And if you are using Ethernet family like Ethernet, fast Ethernet, Giga Ethernet, so in that condition it can be multicast or unicast depending on the message type. Okay.
Okay.
Now, okay, what contents will be there in the update message? Okay, let's see. So we have to generate some update message. See, there is no update here, right? Okay, so what we have to do, we have to
No.
come here. Okay, we have to come here to R1, and normally see here, that's why I have advertised only 12.1 and 12.4. So let's advertise 12.10. So router eigrp 10 network 12.10.1.0.00007. That's it. And now when you send here, see, update message came here, hello ack. So generate some update message. Okay, with the opcode we can understand this one whether. Let's come to know about opcode. Opcode is 5. Still it is hello. Eigrp hello. Okay, no problem. We can regenerate again. What we can do? Conf t
Okay.
uh, no router something like that. Okay. Then we can say here router eigrp10 network 12.1.1.0 neighbor cities up, then 12.10 7, then 12.20. Okay, now if I'm coming to some update message, update, yes, update, updates. Okay, 12.1.1 has updated to. Okay, so let's open the update message. See, opcode 1. Opcode 1 means update message. You can see here. Whenever you see opcode 1 means it is update. Version we are using eigrp version 2. Okay, now see here.
Okay.
Checksum is okay. Sequence number 1. Can you see here sequence number 1? And acknowledgement 15. Okay. Now see,
Yes.
if I'm coming here to ISP, so eigrp neighbor, sequence number 5. Okay, maybe in the last will be sequence number 5. So if you have received some kind of update message, the last update will be, so according to that they will manage the sequence number. Okay, see, sequence number 0,
Okay.
this is hello update, hello acknowledge. So according to those updates, okay, see, if normally what is happening, if I am sending you some update through sequence number 6,
Okay.
right? Okay,
Yes.
so when you will acknowledge me, right? Okay, so you will acknowledge me via 0, right? But you will keep this
Okay.
sequence number 6 in the neighbor table, that yes, I received your information via sequence number 6. Means
Okay.
if next time if you are generating any update message with sequence number 6, means this router
Okay.
2 is not going to accept, because my sequence and the update sequence is matching. Are you understand?
Okay.
Yes, that's
Yes.
why,
Yes.
there is no periodic updates. Okay,
Okay.
yes. And no, it's acknowledge should be 6 here, not acknowledge should be, maybe like I received sequence 6, so I will update you via acknowledge 6. Means so
60.
you will so see, if R1 is sending some update via sequence number 6, R2 will receive, and R2 will also acknowledge you that yes, I received sequence number 6 via acknowledge 6. Okay, and then there will
Okay.
be AS number, you can see here. Okay, AS number. Okay, AS number. Okay, and then there will be some other informations like in update what you have sent. Okay, the network information, so the network information what you have sent here, it will be there.
Okay.
Okay, no problem, let me delete all this first. Stop, stop capturing. And what I will do, I'll come here to ISP. ISP, I will see R1 conf conf t no route Okay. And here no neighborship. Okay, why it's saying neighborship? Here neighbor is okay. So we should say no EIGRP. Let's see that neighborship is down. Yes, neighborship is down.
Okay.
Okay. So let's check the route neighbor. Nothing is there. Okay. So what I'm saying, let's enable again. Start capture. And then once the start capture is there, now I'll come to R1 simply. Okay. Then
Okay. Yeah. Yeah.
network. So I'll say no auto and then network. Let me advertise all at once and then see whether any update is coming or not. Update came and start wires are. So here update I think is a older update or new update. Update hello update. The same update. EIGRP. Okay, see here. So what I told you, whenever you see this update message, so in update message, so in update message you can see here that whatever network prefix you are advertising, right? Okay, and it is
Okay.
internal route or external route,
Internal.
right? Yeah, internal routes. Okay, so it will be
Okay.
there whether it is internal or external. Okay, and then information will be there, the router ID, prefix length, whether it is /29 /30. Okay, and then you can get here prefix is there, prefix type. Okay, prefix type means /24 /30 like that. Then you will get
Yes.
here all the bandwidth, load, delay,
Bandwidth. Yes.
reliability, MTU to check
Okay.
the what?
The metric.
Yes, to check the matrix here. Okay,
Okay.
load, MTU, reliability, bandwidth, delay. Okay, all these things you will receive. So according to these information, you can calculate. Okay, and keep
Yes.
the best information, right?
Okay.
Okay, and then we got hop count. Yes, hop count is also there. Okay. See, next hop. Okay, hop count will be also there. Okay. See, next hop means R1 is sending just to R2. Okay,
Okay.
so like these informations you will get in EIGR. This is sequence number 2. Now let's maybe if you are coming here, whether the information is kept as a sequence number 2, sequence number 3 means maybe you have received some new update. Sequence number 3, acknowledge, acknowledge. See here how it works. If I send update, what is the sequence number? 2, right? Okay. So how I will know that you
Okay.
received update? So you will send update like this. Okay.
Okay.
See, acknowledge 2. I sent sequence 2. So you acknowledge me with acknowledge 2 means I make sure that yes you received it. Okay, like this it works the sequence number. Hello sequence number, for hello sequence number is always 0.
Okay.
Okay, okay. Now content of acknowledge message. Okay, see in the acknowledge
Yes.
message there will be OS EIGRP version. Opcode is 1. See here for acknowledge message. Hello acknowledge. Oh, I stopped it. Okay, no problem. Start. Sorry.
Say,
Okay, opcode is 1. See, for hello, opcode is 5. For update, opcode is 1. Okay, here why opcode? Okay, acknowledge will see what is the opcode. Okay, checksum will be there, flag field will be there. Sequence number according to
okay,
update, sequence number will be there. Okay,
okay,
okay, so if I send you sequence number 6, so acknowledge will be also sequence number 6.
6, yes,
Okay, and then AS number, that AS number means from which EIGRP I am
autonomous,
receiving, and then prefix information that okay, I received this information from you.
okay,
Okay, acknowledgement packets are unicast. Okay, and
otherwise,
this is a delivery is a guaranteed by having packet acknowledgement using acknowledgement packets through RTP protocol. Okay, so these acknowledgements are sent through RTP protocols. Okay, and this EIGRP routing configuration you already know. Okay, so whenever
yes,
we configure, see the first method to configure EIGRP routing, we just normally come here
yes,
and we configure like this and we
yes,
write. Okay, so whenever you are configuring like this means you are configuring as a class less EIGRP routing, right?
class, yes,
So note, if you
yes,
configure like this, then EIGRP router will send classful network updates to its neighbor and it will advertise all your networks related to 1200. Okay, so if you want to
yes,
verify, you can verify via these two protocols. Okay,
okay. So the best way is to configure with the subnet or the
yes,
wildcard
this, yes,
master.
yes.
Mm,
Now, in our
so,
previous class, we have understood about EIGRP topology table. So here also, let's come to know what is
yes,
EIGRP topology table. See, if I'm coming to R1 and if I'm typing here, so IP EIGRP topology, right? So topology means P means
yes,
the constant network. There is no any problem with the network.
passive,
Yes.
yes.
Okay. And here, see, can you see some information? Like, see, with this network, I'm getting
Oui.
FD. But
Mhm,
for this
passive,
network, see, for 1210, I'm getting only FD,
okay,
means feasible distance. But
yes.
for
Physical distance,
1.1.1, I'm getting both FD,
okay,
FD plus RD.
okay,
See here, how I will know that? See, can you see this? This network information detail and this network information detail is totally different.
yes,
Okay, so whenever you are getting only FD, no, see, this is FD, but no RD with this network 12, right? Only FD means these
yes,
networks, whichever networks is there who has only FD, only FD. So
okay,
those networks are my connected networks, directly connected networks on R1. Okay, and whenever
okay,
you are getting any information with network, and here successor is there, no problem. If you are getting plus FD plus RD, okay, then means
okay,
this network I'm receiving via EIGRP. Okay,
okay,
see here if I'm
okay,
getting only this one, see this upper one, here also I'm getting P and here also I'm getting P. Here I'm getting 20, here also is same, here is same. See, this is also same. FD this, FD this is same. But
okay,
here
so it's connected,
via connected, can you see here? It is written via connected. So see here,
it's okay,
it is written via connected means they are my directly connected network. But here via this
okay,
neighbor, so it is written here that via this neighbor. P P
a
means
portable
passive,
distance,
means the router is looking for the sorry, router is
route
not
active,
looking for the route actively, means it is constant. It is in a good
yeah,
situation. But whenever you see
yes,
A means your
active,
network is down. Yes, active means router
mm,
is not in good situation and looking for something. Now with the network you
okay,
will see something like this. See, FD means feasible distance. Okay, and you will
yes,
see something like this 2172 something and 28 something like this, right? Okay, what is the meaning of this?
Okay.
So 21, this one is known as feasible distance, means total distance from source to destination, and 2816,
Yes.
yeah, 28160
Loop-back
means this
distance.
is known as advertised distance received from neighbor. Okay, neighbor.
Okay.
Okay, so here we already came to know about Eigrp topology table. What is the meaning of passive?
Yes.
Why it is in a passive state? How I will know that if any network is in a passive state or active state? Okay, so if you will come here, okay, see, with the help of topology table you can get here. But if you will type here, so active. Okay, do any network is in an active state? Okay,
No.
so here see, Eigrp topology table for AS number 10, ID is this one. This is the ID of that router, and there is no any active routes. All is okay.
Yes.
Okay, Eigrp routing table. In the routing table, you get information like D. Okay, D means
Okay.
Eigrp. Okay, same here. Instead of showing there, I
Okay.
should show you. Yes. Okay, see here. If I'm typing here, so IP route Eigrp. So here we are getting D. D means Eigrp. I'm receiving this
EIGRP.
network from my neighbor. This is the Eigrp. I received this network from Eigrp, and this network which I have received, the autonomous system number is same. This is the metric.
Internal.
Okay, yes, and I received this network from my neighbor. Okay, and this is
Yes.
from last this time. My neighbor is connected with me, right? Okay, now
Yes.
if you want, I should explain you here about the metric if you want. But I do we have any metric calculation? Okay, let me explain you metric, and then I'll explain metric again with another. Maybe see, this is our network, right? Okay, this is our network. Now R1 wants to reach this 1.1.1, right? See how R1 is calculating the
Yes.
metric. Okay, so see, first of all, R1 will calculate this link bandwidth plus delay, right?
Delay.
Bandwidth and
Yes.
delay.
Delay.
Yes. Now here also bandwidth and delay of this loopback interface, right? Okay. So let's
Yes.
check the bandwidth and delay of this interface is E1/0. So come here, R1. So interface E1/0. Bandwidth is 10,000, delay is 1,000. No problem. Come here, write it. Bandwidth is 10,000, delay is 1,000. Come here, ISP loopback, ISP loopback. So interface loopback 1.
Okay.
Loopback is my god. How much is this one? Is it 800,000?
8
No,
million. 8
8
million.
million. 8 million
Yes.
bandwidth and delay is 5,000. So 8 million bandwidth. Okay, and delay is 5,000. So 8 million. Okay. Okay, so for calculating the best one, okay. So what is the formula? Okay, let me delete this
Mm-hmm.
one. Delete it. Delete. So what is the formula? 10 to the power 10 to the power
Okay. 7.
yes, 10 to the power 7 divided
Yes.
by least bandwidth. Now tell me which one has the least bandwidth, the lowest bandwidth. This is even
Yes.
0 or this one?
Yes.
10,000, right?
E10.
10,000 plus
Yes.
cumulative delay, right? Okay.
Okay.
What is the cumulative delay, total delay from R1 to this loopback? 1,000 and 5,000, right?
6,000. Yes.
Yeah, 6,000 divided by 10. So
Okay.
600
Yes.
multiply by 256. We'll see how much is
Okay.
coming here. Let's open our calculator. Okay, so 10 to the power 7, 5, 6, 7. 10 to the power 7 divided by 10,000, right?
Okay.
See, 10 to the
Yes.
power 7 divided by 10,000. So 10 to the power 7 divided by 10,000 is 1,000, right? Plus
Yes.
600 delay,
Mm-hmm.
right? And multiply by 256. How much is there? 409 600,
Yeah.
right?
Yes.
409 600. So come here. Oh, no, from R1 409.
600.
Okay, see here we have only single link, but whenever we will have some lab with multiple links, okay, in that also
Mm-hmm.
I will show you that, okay, from upper link your bandwidth is 59 something, and from lower link your bandwidth is 49 something. So that's why this is best and this one is second best, right?
Yeah. That's right.
Yeah, we'll check that. Okay, topology table is done. Okay, topology is done.
Yes.
Eigrp routing table is also fine. Okay, see, when we will work with different Eigrp, so here you will see if you are working with same AS, you will get D, but when you are getting any network from
Yeah.
different AS
External.
number, then you will get DEX, means Eigrp external
Okay.
Eigrp, right? And you will get here
Yes.
170, right?
External. Yeah. 170.
Yes.
Yes.
Okay, now Eigrp hello and dead timers. Okay, so let me show you hello and dead
Okay.
timers. So if you are coming here, if you type here, if R1, so who will send hello and dead? Interface will send. So you type here, so IP Eigrp interface detail. Okay, or
E1
interface
slash.
E1/0 detail.
Okay.
Why is not coming? Interface detail, detail, detail E0/1. Okay, or E1/0, like 6.
E1 slash.
Yeah. Okay, see here. Hello
E1.
interval is 5 and hold is 15.
15.
Yes,
3 times
yes,
hello.
3 time of hello. Okay, and some other information will come to know. See, there is no authentication set here. Okay,
Not yet. Yes.
if you will get any kind of retransmission, so do you have any retransmission? No retransmission. Okay, no any, there is no any CRC, means there is no any problem in the packet. Okay,
Okay.
now if I will tell you that, no, instead of 5-second hello message, I want to keep that hello message like 10, right? So you can say that, okay,
Yes.
no problem, conf t interface E1/0. You can type here IP hello interval
Mm-hmm.
Eigrp 10 autonomous system number. Okay, and put question mark.
Okay.
Okay, you can get here that, okay, you have to put that in seconds. So if you want 2, if you want 5, if you, but you cannot give more than 15, right? Otherwise your hold is 15
Yes.
and your hello is
Yes.
20, so your neighbor
So
ship
if
will.
you like, if you put 15, you have to maybe put 45 over there.
Yes, yes. And you always keep in mind, it doesn't mean that if you change hello, maybe like if I'm putting hellos 2,
Mhm.
for example, 2. Okay, okay, so if I'm
Yes.
checking here, so it doesn't mean that, see, my hello has changed but hold will never change. Okay,
Okay. We'll
yes, so
still
you have to
remain
change
15.
hold as well. It's not that you change hello so hold will also change. So for hold you have to write here hold time. Okay,
Okay.
Eigrp 10, and then I will say 10. Okay, and then you check here. See,
Okay. For
now
me,
you
I thought that it's gonna be an obligation for you to put it like six. If you put two here for the hero, you have to put six for the hold now.
no, but for better lab or better convergence with the neighbors, your hello and hold should match
Okay.
your with your neighbor also, right? But always keep
Okay.
in mind,
Yes.
see here on E1/0, hello and hold is different, and if you're coming to ISP and if you're checking here conf t show IP EIGR, so
There
IP,
will be no communication.
yes, IP EIGRP interface E0, interface detail E0/0. See here, okay, here hello and hold is different, right? And
No
here hello
impact.
and hold is different,
Yes.
and they both are neighbor.
Yes.
Okay, so in
Yes.
EIGRP, in RIP, if your hello hold is not matching,
Mm.
no problem. But in OSPF, if your hello or hold is mismatched, your neighborship will go down.
Yes. Okay. So in EIGRP, there's no problem
No,
whether it's different or
yes,
not.
in EIGRP no problem, and in OSPF, in RIP no problem. But in OSPF, yes, you have problem.
Okay. They have to match. Okay.
Yes. Okay. Now, from our next class, we will be working in the advanced lesson like EIGRP, equal and unequal cost load balancing. Then we'll work on load
Okay.
balancing. Okay, slowly, slowly.
Okay. Tell me, is there any difference between this one, CCNP security and firewall?
Okay. So in our next session, we will be coming to know about this EIGRP, unequal cost load
Equal and
balancing, equal and
unequal.
unequal. So
Okay.
first we'll work on equal load balancing, then we will work on unequal load balancing.
Okay. Okay. See you tomorrow.